And this nuclear force strongest known forces overcoming Coulomb repulsion between the part protons actually. Similarly, they are part charge independent. Charge independent means that the force of attraction between the part neutron neutron, proton proton, and neutron proton are always part equal. So that is why we can say they are part strong. They are part charge independence. Then saturation property is part each nuclei interact only with the nearest neighbor, which is explains why density nuclear density is almost constant for all nuclei. So because you know that is a nuclear having mass number and it has also a radius. So when you calculate the density of the part nucleus, that is mass by volume, so the density of almost all the nucleus are found to be part equally. So that means that even if whatever may be the part mass number or the part the radius, but they have a part constant the constant per density, and due to that constant density we can say they are have a saturation property, and they can interact part nearly with the part neighbor with the part same force of attraction. Then the spin dependence is what the nuclear forces are simple depends on the relative orientation of nuclear spin, and the deuteron is simple bound only the part spin triplet state. Okay, so this is the part one unique feature that associate the part. This is part your deuteron, so which will be discussed in the part later. Then nuclear force is also part non-central in nature. That means it is not acting from center to center. Rather, it is always active from any point of from the any point of the location of the part particles. Okay, and it has a part also. This nuclear force also has a tensor component, which mix a different orbital angular momentum and explains the properties like the quadrupole moment of the part deuteron. So, so when you can discuss actually the deuteron, the problems of the deuteron, you can find the deuteron actually explains the part different properties of the part this nuclear forces. Okay, so this is the part the idea what is nuclear forces and what are the different key features of the part nuclear forces. So now, and this nuclear force concept actually first established by Aqua Meson exchange theory, and first Aqua proposed actually that is strong force that is arises due to the exchange of virtual meson or the pion particle between the part nucleon, and this theory actually explained both large strength and short range of the interaction, and which is always inversely proportional to that of the part mass of the exchange particle. Okay, and in conclusion or in summary, I can say the nuclear forces are strong, short range, charge independent, spin dependent interaction that bind the part nucleons together. So this is all the part. The key features are the part idea about the part simple the nuclear forces. So I'll provide some of the part questions are the part after the discussion. Okay, means when I can complete, I can give the part some questions related to each of the part section. Then we can come to the part another part point heading that is called the part two body bound state. So basically this two body bound state or the two body problem you can you have read in part classical mechanics or the quantum mechanics. Similarly, in case of also nuclear physics, we have a part two body problem, and in this two body basically consisting of a part proton, two nucleon, that is a proton and a part neutron, and those have formed a part a stable the stability, those are responsible for the part stability of the part nucleus. Okay, and the simplest and the only stable bound two nucleon system in the deuteron, that is in the because in the, you know that hydrogen has the part three part isotopes, that is the protium, deuterium, and also tritium. Okay, and we have to only discuss actually the part this deuterium problem, like which consists of one proton and part one neutron, and other combinations like the two body system may possible like proton proton, neutron neutron, and which do not form the part bound state because of the part nuclear forces which acts alone are not sufficient to overcome the part coulombic repulsion. So that is why the two body, when you are consider two body problem, you have to only consider part a proton and one neutron, one proton and one neutron, but not proton proton and also the neutron neutron. Okay, that is due to the part this nuclear force actually which is actually not explaining all this part two body problem. So that is why we have a limitation that I have also put mentioned here. Okay, now, so when you can go to discuss actually the part mathematical analysis for the two body problem, I just part consider the part two particle. Just you can see the two particle, one is proton and other is part neutron. Let the part masses are part simple m1 and m2, and they are simple situated at the distances. Actually, I just put in a part in one dimension, that is x1 and x2, but actually when you consider the part three body problem, that you can see or the in 3D actually, that you can say R1 and R2 we are consider part in a plane actually. So I consider part in the plane, that is a part sorry, in a part space actually, that is R1. So they are located at a distance R1 and R2. Okay, and they are interacting by a part central potential, that is V R1 R2, which is equal to V R1 minus R2, and which is nothing but equal to part VR. That means, so depending upon part distances, the potential also part also have different, and that is why you calculate the part this potential difference between the part 2 points here. And as these two masses are located at the part different locations, so they introduce a part center of mass and also the relative coordinate, that is R is equal to m1 r1 plus m2 r2 by your part the total mass of the system, that m is equal to m1 plus m2, and that R is equal to part R1 minus part R2 here. Okay, and here that R1 is equal to, I can part if you have the ideas about the part the center of mass coordinate system, then you may calculate R1 is equal to R plus M2 R by M, and R2 is equal to R minus M1 R by M. Okay, so this is the first problem means problematic approach to the part two body problem here. So now we have to calculate in two body problem, that is kinetic energy. So to calculate this kinetic energy, we have to take the part actually the help of the part the Schrodinger's equation, that is total kinetic energy we can find minus h cross square by twice m1 grad 1 square minus h cross square twice m2 grad 2 square, which is equal to a part when you can because these grads are part simple the functions of the part coordinates, that is in three dimensions, that is r and also r1 and r2. So that is why I can put it here minus h square by twice m grad r square and minus your part h square by part 2 mu, and that mu is nothing but the part reduced mass of the part the two body system, and which is given by part m1 m2 by a part m1 plus m2, or if you can split it, you can find this is nothing but equal to 1 by m1 plus 1 by m2. So from which you can calculate actually the reduced mass of the part two body system here. Okay, now so the full Hamiltonian means the total energy of the part the system you can find, that is potential energy plus the part kinetic energy. So you can find that is minus h square by twice m grad r square plus minus h square by twice m twice mu grad r square plus your part potential energy. So this is kinetic energy and this is potential energy, and the total energy part nothing but a part Hamiltonian. Okay, so this is the total energy of the part two body system. Similarly, when you can calculate the part separation in the two center of mass and also the part relative Schrodinger's equation, the same equations that we have to consider here. The total wave function that is separates actually given by psi rr, means r is the part this coordinate of the part center of mass the two body system, and r is the part simple individual coordinate of the part each of the particle. Okay, and which is given by part phi r psi r. Okay, and the Schrodinger's equation that you can find गौरवरी ठीक है काली काली कर देवे okay. So you know this is the part Schrodinger's equation, that h psi and e psi, if you have read the part in quantum mechanics, that you can write. Okay, and the two independent equations that we establish using part these Hamiltonian equations. Okay, minus h square twice m grad square phi r, and that is also part energy equation. So the total energy value is equal to this is energy of the part this for two body system. And when you can just combine the things, just you can find that minus h square by twice m del r square plus v r psi r is equal to E relative, means energy of the part the relative of the relative energy of the part system into psi r, and that is E is equal to part ECM, means energy of the part center of mass, and also the part the relative location of positions of the part two particle. And for the bound states of the pair, we focus on the part relative equations, and we can we just has to be because for a bound system that the relative energy is found to be part less than that of the part is ECM. Okay, so we can consider only the part the center of mass system here. Okay, now you can see, then you can also part able to solve the part radial equation, because when you can find the questions actually you have to find the different equation to just to solve the part different equations, or to just establish the part different equations relating to the part the different properties or the different features of the two-word system. And this is also part one radial equation for the central potential that you may have to get a question. So what do you mean by two-body system? And also establish the part radial equation for a central potential of the two-body system. So you may simply write it here. For a central potential here, we can write actually that psi r is equal to your part so for spherical potential. This is called the radial Schrodinger's part equation here, and that is also the same as that of the part this Cartesian coordinate system. Okay, and here you can find there is a two boundary conditions are there to solve the part this radial Schrodinger's equation, that is ul 0 is equal to 0 and ul r that it tends to 0 when r tends to part infinity, because r part in the located in the part denominator. So for the bound state, you can already have told you part this is e less than 0. Okay, and under this condition, this equation is only part valid actually. Okay, now similarly we can consider also part the asymptotic behavior and also the bound state. That's for a means when you can consider any particle or any particle that is situated the part out of the part the two particle or the two word system which is located at a part another part locations or a particular coordinate system, that you can find this using the part this potential equation that you can also write d square ul by dr square is equal to k square per ul, and where k is equal to twice square root of twice mu e h square. So mu know the reduced mass of system, and e is the part simple the energy of the part the central part this coordinate system actually. Okay, so and the equation or the solution of the part equation you can find is a part simple exponential, and if the energy of the system is simple goes on part decreasing with increase of the distances. Okay, and this is also part square integrable. Now, so we can apply part this as two body problem to the different system. For example, we can solve the part of square wave potential. Just I'm writing that you can also part go just you can see actually for the square wave potential, you know, these are the potential function of a square wave or a square wave potential simply defined by the part potential. And for L is equal to 0, the radial equation that you can find R is part much less than less than equal to A, and outside that is R is greater than A, and for which you can find actually this is the part if you can take the part the previous equation and solve this equation by using this potential, you can find this is a part simple the part Schrodinger's equation in in a finite square wave potential that you have already got in part in quantum mechanics. Okay, now if you can solve these equations, you can get the part solution. Okay, and similarly we can also have got the part normalized on the part also the of the part this square wave potential functions. So or that means the energy what you can get, this is quantized, and this can be normalized by using part this normalization equation. Okay, and there are part also some applications of the part this two body system, and particularly we can discuss actually the part this two body the two body the Newton problem in the next discussion actually. Okay, now I'm coming to part this deuteron actually. So what is the part deuteron? So you all of you know that the deuteron is simple consisting, already I have told, it is simple consisting of a part neutron and the proton, and having a charge equal to that of the proton, that is a plus E, that is 1.6 into 10 to the minus 19 coulomb, and the mass is equal to that 2.014735 AMU, and it obeys simple the Bose-Einstein statistics. So this is called the part the deuteron, and this is deuteron, and it's sum of its part characteristic features. Okay, and the deuteron is the part simple nucleus of the part deuterium, the consisting of one proton, and that is part one neutron. It is the simplest bound nuclear system and provide important insight into the nature of the part nuclear forces. And the study of the part neutron problem involves understanding why the neutron proton system forms a stable bound state while other two nucleon state, that is a protium and tritium, okay, or like a proton proton and the part neutron neutron, do not actually execute the part stable state. So since the neutron has possesses some peculiarity, so that is why we have to enter discussion, we have to concentrate on the this neutron actually. Okay, hello, yes,
Yes, sir.
okay.
Hello, sir.
Now we'll discuss actually some of the part this basic properties of the part neutron. So for example, I have just I've just written very part shortly that here there is a composition of the part neutron, there is one proton and one neutron. its binding energy is found to be for this much. Already that I mentioned here, that the spin and the parity of the part this deuterium is found to be one. That is J pi is equal to 1 plus here. The magnetic dipole moment is found to be this is mu n 0.857 mu n or nuclear magneton. Electric quadrupole moment is found to be for this much here, and the not and they have the part no exact state are particularly observed in case of the part deuterium in the ground state. Okay, there is only the ground state is there, but no exact state actually. Okay, then we are trying to solve the first Schrodinger's equations for the proton-neutron system or means the deuterium system. So this is the part fundamental equation which is part valid for all the part uh, all type of the part nuclear system. That is why I put it here minus s squared by 2 mu grad square plus Vr into psi r is equal to E psi r, and the mu is equal to reduced mass of the system, and the Vi is a part nuclear potential, and this is a part binding energy. For simplicity, we have written here that the potential of the or nuclear potential is simple modeled as a central potential, which often taken as a part squirrel potential, just like we have just discussed actually how to solve the part squirrel potential using the part Schrodinger's equation, and that is nothing but a part aqua type potential. Okay, so that means as fast the nuclear force or the nuclear interaction is observed in part nuclear concept, sorry, aqua potential or aqua concept. So that is why you can say aqua type potential, and which is defined by Vr is equal to minus V0, R is less than R, and that Vr is equal to 0 when R is equal greater than R. That means the potential that we define inside the part the nucleus and outside the part nucleus. And here that R is actually nearly the 2 Fermi, okay, so 2 femtometer in the range of the part nuclear force actually. Okay, now we'll discuss the first same squirrel model in per deuteron, just like inside the means for a you know the for the per inside the part well you have the part r is the part less than r, and you can find actually for this is the solution of the part this Schrodinger's Schrodinger's equation inside the part nucleus, and this is outside the part nucleus, and you are just applying a part boundary condition at r is equal r because we are discussing actually r less than r is greater than r, but r the surface actually the translational equation that is called kx r minus x. So this is the two equations, and these two equations you can find. 1 minute, just my sir is calling, just wait. Hello. Yes. Hello. Priyadarshini. Hello.
Yes, sir.
हाँ अच्छा ସମସ୍ତେ ମାନେ ଇଏ ଗଲା କି ଟିକେ ଡିଷ୍ଟର୍ବ ହେଲା ଇଏ ହେଲା ଟିକେ ପ୍ରୋବ୍ଲେମ କୁହ ହ୍ୟାଲୋ
Yes, sir. ବୋଧେ ସେମାନେ କଟିଗଲେ ନା କଣ?
ହଁ ଟିକେ ତାଙ୍କୁ ମେସେଜ କର ତ
Yes, sir. କରିଛି।
हेलो हेलो
Yes, sir. Message କରିଦେଇଛି।
अच्छा so let me continue that let them join okay
Okay, sir. Okay.
okay so just I've started actually for this square wave potential that I complete the for this just 1 minute Swarup sir hello हाँ ये टिके कौन हाँ रेकर्डिंग चलछि कि अच्छा ठीक अच्छे पिला तो बहुत कम जमा 3-4 जन जमा है हाँ हाँ ठीक अच्छे ठीक अच्छे ओके ठीक अच्छे ओके 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 Um, so this is the first squirrel model solution that already I have discussed with you. So next you can go for the per spin and the per angular momentum considerations. So as already but yesterday also I have told about the for the different angular momentum, that is spin and orbital angular momentum. So the deuteron as consists of two particles, that is one proton per neutron. So the deuteron has spin j is equal 1, that indicate the part neutron proton pair is a triplet spin state, and its parity is part positive. So the orbital angular momentum L must be part even. So just you can see when j is equal 1, the neutron proton pair it is that exists in a triplet in spin state, and its parity is found to be positive. So the orbital angular momentum L must be part even. Similarly, experiment also shows that deuterium ground state wave function is not purely L is equal to 0, means which corresponds to the S wave, okay, but contain a part small admixture of L is equal to the D wave, and this is necessary to explain the part observed non-zero quadrupole moment, which cannot arise from a spherical S state alone. So that is why the total wave functions that is for the deuteron is found to be A psi S plus B psi D. These are the part some coefficients, and that more the mod square of the part B where this coefficient found to be part 4%. And this admixture actually simply indicate the nuclear force contains a tensor component that couples S and part D wave or the D state waves actually. Okay. So finally, that this deuteron problem actually indicate the part this part constitutes the nuclear forces. So the study of the deuteron problem actually leads to several important conclusions. Particularly, you can see the nuclear force is a short range force that already I have discussed with you. Okay, and other thing is what actually it is spin dependent, then the force has a tensor component. So these are all which has the part quadrupole moment and also the part quadrupole moment of the deuteron. And the absence of the bound state for the neutron-neutron and proton-proton system highlights the role of charge independence and spin dependence. Okay, so this is the part basic part ideas about the part neutron problem. Now we'll talk about some of the part nuclear model and also the part nuclear decays. Okay, means particularly nuclear model we'll discuss actually liquid drop model and cell model, and in nuclear decay we can discuss actually that's your part alpha, beta, gamma, all these decay processes. So, because as you have already I told you part that nuclear forces actually basically explained by the part the or the binding energy and the surface that semi-empirical formula for the liquid drop model and also cell model. So let me first discuss actually part what is the liquid drop model, okay, and how the liquid drop model to be helpful in explaining the part the shape of the part nucleus and other features of the nucleus there. Okay, so according to what this liquid drop model actually, and that nucleus is a part simple electrically charged, that is incompressible liquid drop with a mass that varies but has a very high density of 10 to the power 7 kg per meter cube, and that can be used to represent an element like a part nucleus. Okay. Additionally, it is assumed that the nucleon in the nucleus are free to interact with the nearest neighbor, similar to how liquid molecules are free to move about a given intermolecular distance from their nearest molecule. So uh, these are the part some of the following assumptions on which the liquid drop model actually based. So particularly you can get a question, what is the liquid drop model? What are the assumptions made for the part liquid drop model? Then we can go for it part some of the some discussion on the liquid drop model. So particularly the assumptions are there. Surface tension force of a liquid is analogous to that of the nuclear force. It, the constant binding energy per nucleon is analogous to that of the latent heat of vaporization. The disintegration of the part nuclei by the emission of the particle is simple analogous to evaporation of the molecule from the surface of the liquid. Actually, why you are discussing for this nuclear model is a part liquid drop model, since it is analogy to that of the part the liquid drop behavior. So that is why we are putting it part liquid drop model to explain the part structure of the part nuclear. The nucleus of the part nuclei correspond to internal thermal vibrations of the liquid drop molecule, and finally, the formation of the compound nucleus and absorption of bombarding particle correspond to that of the condensation of the part liquid drops. Okay, so these are the actually there are part some assumptions for which we are considering the part the nuclear the structure of the nuclei compared that of the part the liquid drop model here. Okay, then about that liquid drop model, I'll provide actually the details about the part liquid drop, but just I'm giving you a simple liquid drop model. What is liquid drop model and the details here? Just if you can just wait, I'm showing to here. 1 minute. Okay. Hello. Yes.
Hello, sir.
Just I'm sharing some PDF. Just wait. I'm sharing some PDF. Just wait.
Okay, sir.
Is the slide, is the PDF visible to you? Hello.
Yes, sir.
Are you all? Just you can see this PDF is visible to you. Hello.
Yes, sir. Visible.
Okay. See. So this is actually the part. So I just want to talk about the liquid drop model, and let me talk about the part the total binding energy formula for the part nucleus, which are actually contribute to the liquid drop model. So already that I have told you, that's a part volume energy, surface energy, Coulomb's energy, asymptotic energy, and also asymmetric energy, and also the part pairing of and cell energy. So there actually yesterday also I have discussed about the part the semi-empirical formulas about this semi-empirical formula which have contributed by the part volume, surface, and also that you can find the Coulomb's energy, and also that's the part asymmetric energy. These all the things already I have discussed with you. Okay. So now we can also part talk about this part this liquid drop model. Okay, on the basis of the part this liquid model basis of the part also, or the how they can explain by the part this uh, your the surface the surface energy or the semi empirical formula that have to be find. Okay, and finally that you can find also part some of the problems that that I have done, that we have done here, that we can I can share with you. Okay, so so if you can find actually here, so likewise part you can find, suppose you may have got a question like that part, what is liquid drop model. So calculate the part actually, calculate the semi empirical formula for the part liquid drop model. Then you can start actually the total binding energy part nucleus can be constructed by the part following five energy terms like volume, surface, Coulomb, and asymmetric, and the pairing, and the cell energy. So yesterday already I told you part this part volume energy is found to be part AVA, and that's actually this part that age of part actually the mass of the part, mass number of the nucleus, and AV is the part simple the volume of the part nucleus here. And similarly, the part surface energy is found to be part that is ES is equal to 4 pi r square, and R is equal to the radius of the part nucleus. Okay, and that is equal to your part this ES is equal to A. So these are all actually part theoretical approach, because liquid drop model itself is actually your part this theoretical part model. It is not actually experimental model. So that is why this liquid drop model actually completely means completely explained by the part this theoretical concept actually. So the if we can see here, okay, see, so this is the part Coulomb energy. That's also part yesterday that I already part discussed with you for the semi-empirical relation. Okay, and then you are already calculated the part asymmetric part. Then the pairing part already that you have told. Okay, now let me go for the actually to discuss actually to this yes what you can say. Huh. Then you can go to the part nuclear part cell model. So this nuclear cell model actually, I'm not but going to discuss more actually about liquid drop model, because liquid drop model I just told what is the liquid drop model, and what are the part this how the liquid drop model actually assisted by the part the different contribution of the part the different part of the energy that already I told, and already that we calculated for yesterday also. Okay, so let me part go for the actually the cell model. Okay, so this cell model actually you can see this model actually similar to the your part Bohr's atomic model, where the electrons in the extra nuclear space, and by analogy with the part closed subcell and cell in the case of the atom, it is assumed that nucleon also forms a similar uh, closed subcell and also cell within the part focus actually. Okay, within the part the nucleus, which has to be part given the importance on for the discussion actually. Okay, so so here you can find, yes, so these are the part some of the fact about the part cell model. So first of all, you can see the pair of the part nucleons frequently from inside. Okay, that is a single unpaired nucleon can be taken out of the part nucleus more easily than that of a paired one. Okay, because if there is a pair one, there is an interaction, so we cannot break that part interaction between them. So that is why it is very difficult to taking a part nucleon from a single one, from a pairing one, but it is easy to calculate remove from a part single one actually. So the fact that particle has a significant binding energy of approximately 28.3 MeV that sent support the part to this energy. Okay, and the graph between the binding energy per nucleon and atomic number exhibit the numerous techniques, and one of which that is actually so when I've already told you about the part binding energy per nucleon after the part 120 means after the iron and also the part 120 mass number. Okay, that you can find. So how it will be part actually make a part actually getting a peak, then it can be down. So that already explained part yesterday actually. Okay, so this is the part one of the curve that you can find binding energy per nucleon, and this is the part mass number. After the 120, you can find that part how it will be part goes on for decreasing. So this is the part the expansion that written that you can part read here. Okay, and correspond to that of the entire expansion of the part this graph that I put it here. You can find. Okay, then yes, prediction of the part cell model. So cell model actually part given as part within the nucleus. So nucleus are arranged themselves into a closed club cell in a manner that is like to that of the part atoms, the atomic electrons, and thus the cell model is part name given to this. So how? So depending upon the arrangement of the part electron inside the part orbit, actually this cell models are part actually get named, and there is some sort of cell structure to the part nucleon. Okay, that is you can find here uh, to make up the part nucleus, and the protons and neutrons in the proper qualities are used to complete the part subcell. And second thing is part actually you can find this nuclear cell model will be also governed by the part this potential equations. So this may be a part question. So by using the part Schrodinger's equation, you have to solve the part this cell model. Okay, that is already I have written here that you can go through the part details actually when I can share the part material to you. Okay, then I'm coming to part spin orbit part coupling, because I think in the graduation level you have read your part cell model and also the part liquid drop model, so I don't want to kill the time in that. So that's why I just only skip out their things. So now coming to part actually spin orbit coupling. Okay, is the slide is visible? Hello,
Hello, sir.
is the slide is visible to you?
Yes, sir, it is visible.
uh, is the PPTs are visible to you? Hello,
Yes, sir.
PPT is visible now?
Now it is not visible. It has gone, sir.
Okay, okay. Is visible now? Hello.
Yes, sir, it is visible.
Are you able to read the spin orbit coupling?
Mm, yes, sir. Yes, sir.
See, So after the part this nuclear part cell model, just you can see the spin orbit part coupling here. So in order to explain the part the disagreement or the part higher magic number, the mayor independent and Haxel and part Jensen suggested the spin orbit coupling interaction. So which is to be added to the part the neutral of the central potential that is describing the part cell model. So taking spin orbit interaction into account, the sequence of the energy level is simply designed as a part 1s1, 1s a half, 1p 3 by 2, 1p a half, 1d 5 by 2. So these are the part different part actually the energy level which will be part actually explain the part this cell model. In accordance with the part this Pauli's exclusion principle is available for a given J can be accommodated the maximum 2J plus 1 nucleons of either kinds, okay, or which the magnetic quantum numbers M are per different are found to be per different. Similarly, when you can take also part this J is equal to J minus 1, then the part J minus 2 like that part, okay, that you can find a completely field of cells with the part 2J plus 1 nucleon for particular kind. Similarly, the group of sublabel of N, L, J having energy values are close to one another and which they constitute part nu cell, and all these part actually the occupancy of the part this is the electrons inside the part the cell that can be part arranged in a part in a cell structure like that actually. So for the lowest level, according to the part the scheme, 1 is to this J is equal to 1 by 2, which contain actually this number or the two nucleons. Okay, you can see here. Similarly, for 1p cell, you can find 8. Similarly, for the 1d, you can find 20. Like that part, when the cell number is part goes on part increasing, the occupancy also part goes on part increasing here. Okay, so now we are coming to the part angular momentum and the particle and also the part parities for the part nuclear in the ground state. So particularly in this angular momentum, as already yesterday that you have read the part the two type of part angular momentum, orbital and also the part spin. So the total angular momentum is equal to the part L plus S. So the magnitude of the total angular momentum is given by J is equal to square root of J into J plus 1 h cross, and J can be take the any half integral value of depending upon the part the particle spin here, and the magnitude of the spin angular momentum is given by part S is equal to S into part this square root of S into S plus 1 into H. Okay, then where S is found to be per spin angular momentum quantum number, and the magnitude of the orbital angular momentum is given by part L is equal to this much here. Okay, so then quantum mechanical considerations show that the total orbital and the spin angular momentum of the part nucleus that is given by part this I into L plus I plus 1 s square, then PL square is equal to also L into L plus 1 s square. Then you can find P square also spin that is AC into S plus 1 into S plus square. Okay. Then and the nuclear spin is always part 0 for I is equal to 0 for even Z and for even part N nuclear. Okay. Then according to the part measurement of the ground state spin of the part nuclear. This value is actually found to be 0 for even nuclei according to the part the ground state spin of the part nucleus, and this demonstrates actually the nucleus inside the part nucleus have a tendency to pair up into a part nucleon like pairs where their angular momentum are equal and also the part oppositely part aligned actually. Okay, so this is the part value that we can find. You can from here part the total angular momentum that is shared by the part both the spin and the part orbital angular momentum. Okay, now after that uh, I have to just touch with the part this alpha particle and also the part beta particle. Okay, so let me hello.
Yes, sir.
uh, so actually let me think chat tomorrow actually I have some is there any can we extend this class to another for tomorrow's class another day.
Yes, sir.
क्योंकि
Yes, sir.
actually because actually from tomorrow actually our means our holiday is starting actually, so I have to be leave uh, and the leave office. So that's why can it is possible for any other day if you can then you can I can talk to them. Okay, because because tomorrow is 26, na.
Yes, sir.
So tomorrow I think our last working day here, so I have to leave. Hmm. So I can I'll take for two more classes and I can finish up for the entire course actually. Okay, otherwise I can share the part material to you. Hmm.
Okay, sir. So after
Tell me, Priyadarshini.
holiday is there, no, sir?
Yes,
For 27, we are also holiday in this class.
27 you have the holiday, na?
27 to 6. After 6, nano science will be start.
So yes.
After holidays, class will be start.
Huh. So I need only for two more classes actually, because the 2 days because actually 24 class actually say 23 class 23 date I am not able to take the class. So that's why I just miss one class actually. And only another day is there 26 and 23. Let me, if possible, tomorrow I'll take. Otherwise, it will be. I'll be informed. Okay.
Okay, sir.
Hello.
Okay, sir.
Okay. So let me stop today. Then I'll be share it the slides to you. Then you can share to others. Okay. I'll share the part
Okay,
all these
sir.
PPTs. Okay. Okay.
Yes, sir, in which day it is possible for next class? I will take that class.
Please tell me
Maybe,
actually, but loudly because it's not audible actually. Please tell me.
sir, which day we will take this class? मतलब, means you will take this class in which day?
So
Means
is it
in
possible?
holiday only?
Uh, tell me.
In holidays only or after holidays?
So I don't know actually because 27. So your 27, 28 is for Saturday, Sunday. 29, 30 is holiday.
Yes, sir.
If holiday is there, because whether they are coming or not, I don't know. But if they are not, then I can take actually 29 and 30 also. Then I can finish. What will do? Let me talk with upper center. Okay. Hello. Hello.
Hello,
Hello.
sir. Hello, sir.
Let me talk with
Hello.
upper,
Hello.
let me talk with upper the center. Okay.
Okay, sir. Sir,
So
we
yes, tell
we
me.
will have next class is there after holidays means 6 October 6.
Oh, October 6.
26 tomorrow, no? Tomorrow is this nuclear physics class will be
तुम्हें ODR को
finished. But
प्रियदर्शनी ODR को I can understand.
ସେ କାଲି ଆପଣଙ୍କ କ୍ଲାସ ଲାଷ୍ଟ ହଉଛି ନା?
हाँ
ତ
କାଲି ମୋର କ୍ଲାସ୍ ଲାଷ୍ଟ
ତାପରେ
ଅଛି.
ହଲିଡେଜ ହଉଛି, ତାପରେ ଦଶରା ହଲିଡେଜ ଅଛି।
ହୁଁ.
ତ ଆମେ ହଲିଡେଜ ବାଦ କରିବା ନା ଏଇ ହଲିଡେ ଭିତରେ ହିଁ ହବ ବୋଧେ?
ହଲିଡେଜ ଭିତରେ କରିବ କି? ହଲିଡେଜ ଭିତରେ ତମ ସେଣ୍ଟର ଖୋଲା ହେଇଥିବ ନା?
ଆଚ୍ଛା, ସେଇଟା ମୁଁ ପଚାରୁଥିଲି। ତ ହଲିଡେଜ ପରେ ହିଁ କରିବା।
ଆଚ୍ଛା ଠିକ ଅଛି, ମୁଁ ସେଣ୍ଟର ସହିତ କଥା ହେଇକି ଟିକେ ଲାଇନରେ ରୁହ, ମୁଁ କଥା ହେଇକି କହୁଛି ହେଲା.
ଓକେ।
ଜଷ୍ଟ 1 minute ୱେଟ୍. Okay, so after talking with you, I will inform you. Okay, Priyadashini,
Yes, sir.
just let me, because they are not responding now. So after that, I will be informed you. Okay.
Sir, yes, sir. If you will inform, then I will share that one.
Okay. 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 Thank
Okay,
you.
sir. Thank you.
Let me leave.
Thank you, sir.
Thank you,
Okay.
sir.
Sivram,
Yes, sir.
so what you're saying? Tell me.
Thank you, sir.
Uh, Sivram is not audible actually. Please tell me.
Thank you, sir. Thank you.
Okay. Okay. Okay.